4.2.6 Saddle bends. Saddle bends are used to cross small obstructions or other runs of conduit. Saddle bends in conduit with an inside diameter up to 4 inch may be made in a hydraulic conduit bender. Always refer to the charts that accompany the bender. Here's a highlight. It says, for example, to make a saddle bend on a length of 2-inch rigid conduit so that it can pass over a 3-inch water pipe with 1/4-inch clearance, 3 bending operations are required. Bend is calculated by referring to the appropriate bending chart. The chart shown in Table 4 gives the measurements for a 2-inch conduit with a 1/4-inch clearance. Therefore, look in the left straight run conduit column and go down until the 3-inch row is reached. Moving to the right in this row, note that the spacing between the bends is 15 5/8 inches on center, and bends number 1 and number 3 will be 15 degrees, while the center bend will be 30 degrees. So they're saying we'll go down to 3 inches and bend spacing to make a 3-inch clearance. It's 15 5/8 inches. All right. So degree of the first bend is 15 degrees, the second bend is 30, and the third is 15. It takes that much conduit in order to load it into the hydraulic bender. So we have to make sure that we have more than 14.5 inches between our bends. We need to be able to clear the first bend and get to the center of the second bend to make the 30-degree bend on the second bend. So let's see here. So we'll make first the 15. This is called the push-through method. You bend the bends in order, 1, 2, 3. So you bend the first 15-degree bend, push the pipe to the center of the second bend, and rotate the conduit 180 degrees with a no dog on the conduit. Bend the 30-degree bend, and then push the conduit to the third bend. Rotate the conduit again 180 degrees so that you're in line with the first bend, and make another 15-degree bend. That will give you your 3-bend saddle to go over a 2.5-inch obstruction with a 1/4-inch clearance. It's going to make a 3-inch 3-bend saddle. Using the information found in the bending table, mark the conduit accordingly, insert the conduit into the bender, and make the bend number 1 at 15 degrees. Remember, spring back. We might want to go to 16 or 17 degrees. Back off the pump pressure, reverse the conduit in the bender, and then make the bend at mark number 2 at 30 degrees. Back off the pump pressure, reverse the conduit in the bender, and then make the bend at number 3 at 15 degrees. Each time going a couple degrees over. So like 17, 32, and 17. Release the pump pressure, remove the conduit from the bender, and check the saddle for accuracy. So here they want to make a 4-bend saddle. Usually a 4-bend saddle has a wider obstruction, more rectangular. So we would make 4 bends, all of the same degree. We're in essence making 2 offsets to make this 4-bend saddle. So I won't go over the math. They're going to figure out how far to the center. They're going to take the shrink of one of the bends and add it to the conduit so that when they bend this offset, the shrink will bring the center of this 4-bend saddle to the center of the obstruction. All right. And here they're telling us it's 6 feet. It's 3 feet to the center of the obstruction. It's another 3 feet to the junction box. So, like I say, we would have to figure the shrink of one of these. A 45-degree bend has a shrink of, I believe, 3/8 of an inch per inch of offset rise. So if it's a 10-inch, we're talking 30/8 or what is it, 3 3.5 inches of shrink. So instead of putting this at 3 feet, we're going to put it at 3 feet, 3 1/2 inch to the center. Then we'll measure back 5 inches and 5 inches for the edges of our obstruction, and then we'll put the length of how far apart we need these, 1.41 for 45 degrees should be times 10 inches. It should actually be 14.14, but you know, who's counting? Oh, they're saying we're going 11 inches. Okay, that's why. They wanted it to go an inch above the obstruction. The obstruction's 10 inches, and they want to go an inch above it. So they're actually going 11. That's how they came up with a 15.55. All right, very good. Centerline layout mark for the saddle will be 3 feet if the conduit were to be installed in a straight line from the end of the existing conduit to the center of the I-beam. However, the conduit's not being installed on a straight line. Measurement must include the amount of additional conduit needed because of the 45-degree angle of deviation. The amount of additional conduit is equal to the side adjacent subtracted from the hypotenuse. So it's the adjacent side. It's a 45-degree bend. And it's the amount of shrink that it moves. Side adjacent needs to be calculated, then the measurement can be subtracted from the hypotenuse, 15.55 inches. To calculate the side adjacent, use the cosine formula. Cosine equals adjacent divided by hypotenuse. So they end up with the cosine 0.707 times the hypotenuse. They got 10.99 inches, 11 inches. So if we subtract 11 inches from this 15.55 inches, we end up with 4.55 or 56 in their case. So that's how much we need to add to the conduit in order to have the layout work. All right. So that's what they did here. They've got their, instead of 36, what do they do here? Oh, 40.56 minus the 5.5. All right, equals 35.06. Why? Why did you do that? What did they just do? Oh, that's how much extra conduit is needed to get the center of the saddle to the center of the I-beam. Therefore, the layout mark of the saddle is calculated as shown in the following equation. So they got 3 feet plus the 4.56. 3 feet 4.56 or 40.56 inches. Okay, so they added it to it. It's 40.56 inches. And the deduct for the 90-degree bend, 1-inch rigid metal conduit, is 11 inches. Since we're using 45-degree bends, we must use half of this deduct. So the deduct for a 45-degree bend is going to be 5.5. Oh, that's what they're doing. Okay, they're trying to find their start mark. I would just bend to the center of the bend. It's a lot easier to bend these saddles at center of bend than to try to find the start mark, and that's what they're doing. They're finding the start mark. So here's your 15.5 and your 5, and then you'd have to adjust this at 5.5 inches longer because of the shrink. All right. Distance between bend points on the top portion of the saddle is 10 inches. Distance between the bend points that form each hypotenuse is 15.55 inches, or you could just say 15 and a half. And 5/100ths of an inch really isn't going to make that big of a difference. And the distance from the end of the conduit to the center line layout mark of the saddle is 35.06 or 35 inches. Bending will be performed in a linear progression from one end to the other, rotating the conduit between the bends necessary. Note that the total length of the conduit is dependent on the conduit size and type, as well as the type of bender. Always follow the manufacturer's instructions for the bender being used. All right. Magnetic level, yeah, they're saying that you can use that for laying out your bends. It's very good to have those. Here's a saddle bend going around a conduit. Here's another one on the other side. Sometimes you do what you gotta do. Here's the section 4 review. To make a 90-degree bend in rigid metal conduit, the conduit may be bent to 95 degrees to account for spring back. A hydraulic bender is not maintaining its rated hydraulic pressure. This is most likely because low fluid pressure. You need to take a look at the amount of fluid in it. Add some fluid if necessary. Installing PVC conduit. Now, PVC is a little different than rigid metal conduit or IMC or EMT in that it needs to be heated before you can bend it. So, rigid polyvinyl chloride electrical conduit and fittings may be used in direct earth burial in walls, floors, and ceilings of buildings, in cinder fill, and in damp or dry locations. The National Electrical Code prohibits PVC conduit in certain hazardous locations as support for fixtures or other equipment where it's subject to physical damage and for various other applications. Refer to Article 352. Caution: PVC electrical conduit must be listed for electrical use. PVC pipe used for plumbing purposes and similar applications is not typically used for electrical use. So don't use the gray pipe. Don't use the white pipe, use the gray pipe. PVC pipe for plumbing is typically white. PVC electrical conduit is typically gray due to the addition of ultraviolet light protection. So do not use plumbing pipe for electrical. PVC conduit can be cut easily at the job site without special tools, although PVC cutters help in cutting square ends. Sizes from 1/2 to 1.5 inches can be cut with a fine-tooth saw or PVC cutter. Square cuts are easier to make when a miter box is used. Let's see how they join this together. They're going to use glue. An important advantage of PVC conduit compared to other rigid conduit materials is the ease and speed at which the solvent cement joins can be made. The following steps are required for proper joint. Make sure that they're clean. Ensure the conduit's clean and dry. Apply an even coat of PVC cement to the end of the conduit and to the fitting. The cement should cover the area that will be inserted into the fitting. Push the conduit and fitting firmly together with a slight twisting action until it bottoms out, and then rotate the conduit on the fitting about 1/2 turn to distribute the cement evenly. Avoid cement buildup inside the conduit. The cementing and joining operation should not exceed more than 20 seconds, and then leave it alone for a minute. Let it dry, let it harden. When the proper amount of cement's been applied, a bead of cement will form at the joint. Wipe the joint with a brush to remove any excess cement. The joint should not be disturbed for at least 10 minutes, it says. Curing time varies and extended in humidity or cold weather. Here's a warning. This is a highlight. Provide adequate ventilation. Avoid skin contact and always refer to the safety data sheets and follow manufacturer's usage and safety instructions. Because PVC glue has vapors, and you want to have a well-ventilated area. You don't want to be breathing those fumes. Bending PVC. Here's a PVC hot box. It's got electric heating elements on the side of it. Here's a small one for smaller pipe. Here's a large one for larger pipe. While some heaters use propane or natural gas as a heat source, most use infrared heat. Small diameters are ready to bend after a few seconds in the hot box. Larger diameters require 2 or 3 minutes depending on the conditions. Other methods of heating PVC conduit for bending include heating blankets and hot air blowers. The use of torches or other flame-type devices is not recommended. PVC conduit exposed to excessively high temperatures may take on a brownish color. Sections showing evidence of such scorching should be discarded. So be very careful. If you have to use a torch, keep it moving. Move, move, move. Don't let it sit in one place. Keep it moving. All right. So here's a plywood template. So when you get the pipe nice and soft, you can put it in and bend it around that corner and then cool it off with some wet rags. If only a few bends are made, scribe a chalk line in the floor or workbench, then match the heated conduit to the chalk line and cool. The conduit must be held in a desired position until it's relatively cool, because the PVC material will tend to revert to its original shape. Templates are also available for many bends. Another method is to take the heated conduit section to the point of installation and form it to fit the actual installation. This method is especially effective for making blind bends or compound bends using smaller sizes of PVC. After bending, wipe a wet rag over the bend to cool it and to set the bend. So here they're making an offset in the pipe, and again they're bending it blind, meaning they didn't take measurements. They're just gonna put the PVC in one end of a coupling and then bend it to shape and let it cool. Wipe it with a rag. When it's ready to go, they'll take it out, use the glue, and then set it. Bends in small diameter PVC conduit up to an inch and a half require no filling for code-approved radii. When bending PVC 2-inch or larger in diameter, there's a risk of wrinkling or flattening the bend. To help eliminate this problem, a plug set is used. A plug set is inserted in each end of the piece of PVC being bent, and then the conduit is pressurized using either a hand pump or the heat of the bender. So place airtight plugs in each end of the conduit section before heating. The retained air will expand during the heating process and hold the conduit open during bending. Here's a plug set, and they come in pairs. You seal off the PVC, and then as you heat it, the air inside expands, and it puts outward pressure on the walls of the PVC, hopefully keeping the PVC from collapsing. If you heat 3 or 4 inch PVC and you try to turn it on 90, a lot of times the PVC will be too soft and it'll just collapse in on itself. You can't have that. Let's see here. What else have we got here? Table 5 PVC expansion rates. All right. Expansion couplings are seldom required in underground or slab applications. Expansion and contraction may generally be controlled by bowing the conduit slightly or burying the conduit immediately. After the conduit's buried, expansion and contraction cease to be factors. Care should be taken in constructing a buried installation. If the conduit should be left exposed for an extended period during variable temperature conditions, an allowance should be made for the expansion and contraction. All right. They do have expansion joints for PVC conduit. Section 5 review. When joining PVC conduit, apply PVC cement to the end of the conduit and the fitting. In preparation for bending, large diameter PVC should be heated for 2 to 3 minutes at least. And you should use a plug set, plug the ends of it. That way it expands, the air inside of it expands and it keeps outward pressure on the walls of the conduit, keeps it from collapsing. Well, this concludes 26204 conduit bending. As always, I hope you got something out of it. If you did, give me a thumbs up and consider subscribing to my channel. And as always, I'll see you on the next video.